Thank you so much, Robert. And yeah, thank you for joining me this morning. As we all realized, it's a little bumpy today, so I was not sure how many people will actually leave their cabins, but thank you for joining me. Now, today we're gonna, well, on our journey to Iceland, we're gonna explore volcanoes in Iceland. And I'm gonna start with a few general points about how volcanism in Iceland comes about. And then I'd like to give you the Premier League of Icelandic volcanoes. I'm gonna introduce you to all of them one by one. Well, not all of them, but the most important ones. Now, Iceland has been a place of fascination and mystique for many, many centuries. And this is one of the old Dutch maps, which I have up here. And here you get the idea of the shape. And the Dutch were magnificent sailors, so they drew all these maps. But they also put in a few, well, ocean beasts, if you look at the lower part there. And there is a lot of information in there. And the information here says the seas are treacherous. And if you look very carefully, maybe it's a little small, you can even see some polar bears in the top right-hand corner on some of the icebergs that are floating around. So there was a lot of information. And in the center of Iceland, there is this volcano that's blowing up. Let's see whether I can highlight this a little bit here. So here, this is Hekla volcano. There's a big eruption, and Hekla was for a long time believed to be the entrance to hell. So Iceland has been a fascination for many people, and a lot of legends surrounding it. So let's see how much of it I can clarify today. So today we're gonna look at the journey from the center of the Earth. Not a big secret, it's an analogy to Jules Verne, the journey to the center of the Earth, but magma comes the other way, it rises upwards. So I'm gonna go with you the other way from Jules Verne's trip, and we're gonna look at where the magma comes from, how it rises up, and what volcanoes are fed by it. We are obviously in the northern part of the globe, very high up, and Iceland is, well, sometimes very icy, but it's also very fiery. And there is a bit of a story about the naming. You may or may not know when the Icelanders, well, discovered Iceland. It wasn't a very popular place. Only people who weren't happy in Norway were actually moving to Iceland. When the Icelanders then discovered Greenland, well, they called it Greenland because it had a lot of ice. And they wanted settlers to go there. So this was a ploy, calling it Greenland, and they go, oh, well, Iceland doesn't sound good, Greenland sounds a lot better. Well, you know, advertisement always had a role to play. But Iceland, of course, is actually more fiery, certainly for most parts, and this is because of the Mid-Atlantic Ridge and something else, a plume, and I'll come back to this later. The Mid-Atlantic Ridge system spans around the entire kind of Atlantic, and it goes beyond the Atlantic, then we call it mid-oceanic ridges. These are fracture systems that are 60,000 kilometers long, all around the planet, and there the plates spread apart. The Atlantic spreads with about 2 centimeters a year, so it's a very slow process, and only over geological time will you actually see the effect. So here we have a little map, and this is a geophysics map, and there you see the spreading, the more intense colors on the right-hand side, the red colors. This is where new material is forming, and Iceland has this zone of spreading running through it. It forks a little bit towards the south. There we have the northern volcanic zone, NV set on that map, and then we have the western volcanic zone, WV set, and then we have the Reykjanes volcanic zone. This is where we have currently all the volcanism, and these are considered plate boundaries. People always say there is this wonderful magic place where you can put 1 foot onto the North American plate and 1 foot onto the Eurasian plate. Well, it's not as straightforward as that, I'm afraid, because you need quite a wide footing in many of those places. And it's a little less well-defined as some people claim it is, but it is true that the plates are spreading apart there. And there we have these beautiful sites. If you have the opportunity, you may want to go to Thingvellir. This is one of these spreading ridges. And there, the Icelanders had their parliament, their early parliament. It met there, and it's on the Golden Circle. So I recommend having a look if you have a chance. So this spreading has been going on for about 14 million years. Well, it's been going on for longer, but Iceland, the oldest rocks in Iceland, they formed about 14 million years. And the youngest rocks in Iceland, they're about a month old because they just erupted in June of this year. So when we're sailing around Iceland, when we're going up to Ísafjörður, etc., there we see some of the old rocks. And here's a little reconstruction on the right-hand side, how Iceland may have looked like 11 million years ago, 8 million years ago, and how it might look at the present day. So this spreading is a key feature, and it continues. But the entire Atlantic is spreading. So one of the crucial questions geologists ask is, why is Iceland above sea level? Why do we see this? Because all the other spreading centers are submerged, they're under the water. Well, this is because Iceland has a little trick up its sleeve. It's called a mantle plume. This is a similar feature to what we have on Hawaii. This is why we have punctual little islands in Hawaii, and this is the same here. This is a heat anomaly, a hotspot, as geologists call it, and this produces extra volumes of magma. Now, the spreading of the Atlantic and the hotspot together, they make for Iceland being such a prolific site. And here on the right-hand side, we have a little map with Iceland in the center. When Greenland and the British Isles were still together, or Canada, the British Isles and Greenland were still together before the Atlantic spread in a major way, there we also produced a lot of magma. It's given in red colors here. And the initial spreading was also caused by the Iceland plume, but it's still continuing, and the plume is still going strong. It's causing the volcanism there. So this plume, well, people have been speculating about the origin of magma. This is a drawing by Athanasius Kircher from the 1680s. And he had already this notion that there was fire inside the earth, and it would come up in stems or fire streams. And present-day science has advanced a little, but not too much, actually, because today we think it looks like this. So here we have different plume arrangements, and we have plumes all over the planet. The Canary Islands are plumes. We have the Hawaiian Islands, the Galapagos Islands, and of course Iceland. And the Iceland plume sits, let's see, sits just up here. You can just about see the little arrow. And here's different kind of reconstructions of how things may have changed. Maybe it forked a little bit for some time, but the Iceland plume is going for millions of years now. Where do these plumes come from? That's a fundamental question, and if I'm really honest with you, we're not entirely sure. But there is a deep Earth reconstruction, and given the chemistry of most of the plume magmas, we believe it has to do with formerly lost continents. Long ago, continents that existed were again subducted into the Earth, and they bring a lot of radioactive elements with them. These decay over time, these heat up their surrounding, and then this hot material might rise up. This is consistent with the elevated heat, and it's consistent with a special chemistry of Icelandic and Hawaiian and Canary magmas. So this is the origin of this. These plumes, they come probably from the core mantle boundary at 2,900 kilometers depth. That's the very origin, and that's the journey this material makes. But the journey is not made by magma. It's actually solid rock that's rising up, and only about 100 kilometers below the Earth's surface will the rock actually melt. Deeper in the Earth, the pressure is too high, and it can actually not melt, but it's warmer, and therefore, over geological time, this material is moving up. So, to summarize this, we have this spreading center in the North Atlantic, and we have the plume, and those together create this very unique and special situation. Near the surface, however, this plume-fed and spreading-fed magmatism creates a number of volcanoes. So volcanoes are fed, of course, from the interior of the Earth, and the magma that ascends may actually collect in the crust below a volcano, and a fraction of it may eventually reach the surface. There it can erupt as lava or as pyroclasts, meaning broken by fire. This would be explosive eruptions like ash. And we have a whole series of those volcanoes. We have central volcanoes and fissure volcanoes, and in Iceland we have about 30 larger volcanic systems. So here's a list of all of them, and I don't have time to go through all of them in detail, but we'll do the highlights, as I said, the Premier League of Icelandic volcanism. And we're going to start in the western side of the island of Iceland, and then we're going to move around the southern coast, and then we're going to move north. So that's the idea for introducing you to the main players on the Icelandic volcanism scene. A quick note before we go there. We have effectively central volcanoes. These are the cone-shaped, beautiful volcanoes. They form by continued eruptions over longer periods. And then we have fissure eruptions, meaning cracks that open up where magma comes out on these long, long fissures. And these are usually of basaltic nature. That's a low silica magma. There we have a lot of lava, and they tend to be less explosive. They can be harmful as well, but they tend to be a little less dangerous. Yesterday, if you had an opportunity to join me, I was talking a little bit about volcanic hazards, so a quick recap of that. We have hazards close to the volcano, the direct ones. This is lava flows, glowing avalanches, and things like that. Ashfall can reach a little bit further from the volcano, possibly hundreds of kilometers, even thousands. When you think of Eyjafjallajökull 2010, there the ash was reaching northern Europe and actually even central Europe. And if we have big eruptions and they're very unpleasant and the ash goes very high into the stratosphere, we could even have climate effects for years after an eruption. Well, not many Icelandic volcanoes have really had large climate effects, but some did, to be honest. So now let's plunge into the Premier League. And this is one of my first Icelandic volcanoes that I've experienced, and this is Snæfellsjökull. Well, it's also sitting in the very western part, and there's the Snæfell's Peninsula. It's a little further from Reykjavik, and Snæfellsjökull has a glacier on top. Jökull means glacier, so there is a glacier sitting on top of the volcano, and the mountain actually had the biggest claim to fame in Jules Verne's book, The Journey of the Center to the Earth. Because Professor Liedenbrock, he took his team out there, and he was leaving Hamburg in northern Germany, sailing up to Iceland, and there he looked around trying to find the entrance to the center of the Earth. And he found it at Snæfellsjökull. So that's where he went into the center of the Earth, and eventually he had to come back, and he found a way back out of the Earth, and this happened to be at Stromboli. And Jules Verne implied that somewhere deep down, all of these magma sources are connected. Well, Jules Verne had no idea about volcanoes, really, let's face it, but he had this notion that there must be some inner source of heat and that connects it all, and in a way, he has a point with that. So, this is Snæfellsjökull, and you might not have a chance to go there. It's a bit remote, it's a long drive, but if we're kind of sailing along the west coast, you will see Snæfellsjökull on the horizon, I promise you that. The next one I'd like to share with you some information about is Fagradalsfjall, and this is the eruption seen over the last 3 years. Fagradalsfjall is not a central volcano, it's a fissure-type volcano, and it had eruptions a few hundred years ago. It fell dormant, and now it seems to reawaken. There was 8 eruptions in the last 3 years alone, and we have to be realistic. There will likely be many more in the next decades. So this volcano has jumped back to life, and it's now producing quite a nice lava field. So the thing is that after about 800 years of dormancy, this volcano wakes up again, and you can actually see this. This is a view from the other side of the Reykjanes Bay. So you can see Reykjavik, and behind there you see the eruption cloud of Fagradalsfjall. It's only about 40 kilometers away from the capital of Iceland, and that's pretty close. It's also about 30 kilometers away from the international airport, and it sits in a rather unfortunate spot. The eruption started in a very remote area in 2021, March 2021, and there we had these stunning lava flows. Nobody was harmed, there was no grazing animals, everything looked super nice. You could go there, the lavas were not too dangerous, you could pick them up with a hammer, so quite spectacular. Then, well, the eruption continues, more lava comes out, and suddenly it got a little serious. Because the lava started to spill into valleys, and the valleys obviously mean that lava is moving towards the lower ground, towards the sea. And there we have coastal roads, so there was a big concern that these coastal roads would be truncated, but it didn't happen in 2021, luckily. What happened, however, is that literally tens of thousands of people came to Iceland to see the volcano. And this was during COVID time, remember. Iceland is strongly dependent on two industries, and that is fishing and tourism. And during COVID time, tourism was not a big thing until the volcano erupted. So many people actually claim Iceland was saved by a volcano, otherwise there would have been another financial crisis. So the bankruptcy was avoided, the volcano erupted, and here you see literally thousands of people going to see the volcano. The restrictions were very low. You could actually go there. There's loads of YouTube videos where people do silly things like, well, having barbecues on lava, or putting in, well, the weird thing I saw was somebody puts in a can of Coca-Cola, and of course it explodes after a minute, and things like that. So people were doing this, and towards the end of 2021, the volcano calms down again, just to reawaken a year later, a little bit off, a little bit towards the west at a place called Meradalia, and this was also towards the end of COVID, and there we had another little volcano forming. This is the Meradalia cone, and it produced a nice little lava field of its own right. We had a lot of time to exploit the situation there as geologists, so here we practiced our sampling skills and practiced all sorts of equipment, and I can talk about this a little more in one of the future presentations, but we got hundreds of lava samples. Quite fascinating. So far, the volcano was still harmless, let me remind you, but just towards the end of last year, the activity suddenly jumped towards the west. And we had 3 eruptions on Fagradalsfjall. This is given here on the right-hand map in yellow, green, and blue, 21, 22, 23, and suddenly it jumped towards the west. And then we had 5 eruptions within half a year at Sundnukur. And this is actually the real dangerous eruptions now, not because the eruption style is different, but because we have settlements and infrastructure there. And the town of Grindavik at the port, with its port at the southern coast, this town is now heavily affected by the volcanic eruptions. And the red area on the right-hand map, that's the evolving lava field. The map is only about 2 months old, but it's already outdated. The lava field has grown already since we made that map. So earlier this year, the lava was spilling into the town of Grindavik, and the Icelanders have put up lava barriers. It's quite effective, but suddenly a vent opened up inside the barrier, and it produced a lava flow that entered the town. All the people were evacuated, so that's good news. It's only financial loss, it's only damage to infrastructure and properties. One accident occurred, one person unfortunately died, disappeared in a crack, but this was one of the civil protection personnel, so it's not that the volcano killed that person directly, but these things happen, of course. And there's still swelling going on. Right now, the swelling is so strong that the Icelandic Meteorological Office warns that we might have an eruption within the next week or so. And yes, if we are lucky in inverted commas, we might actually see it, because we'll be sailing by. Here's a few impressions. I've visited the site earlier this year, several times in fact, and there we have the lava that intruded into Grindavik town, and with a special permission you can go there and can sample it. And you see, well, some of these houses, well, they didn't really have a good chance to survive when lava comes. But let me show you this. If I was the owner of that house, I would open a company here and I would say, I have the fence that can withstand the magma. Well, the metal ones in the lower left, they can't, they're no good, but my wooden one, that would do the trick. So I'm sure somebody will come up with this idea sooner or later. So, as I said, we'll have more eruptions there over the next little while. This is unavoidable, but the Icelanders, the government has now offered a buyout scheme. So you can sell your house in Grindavik, if you have one, to the government, and you can resettle somewhere else. So the people should be fine. The financial damage, however, that's a different issue. Now, I'd like to take you to the next volcano now. We're moving along the south coast. In the little map in the top right, there's a star. That's the position of Hekla, and Hekla is a proper stratovolcano. For a long time, Hekla was believed to be the entrance to hell. I don't think it's quite so bad. But here we have a big stratovolcano, about 1,500 meters tall, and that means there was many eruptions over quite some time, and it had quite a series of recorded eruptions in historical time. Since the settlement in the 800s, we had about 20 recorded eruptions there. If you go close to Hekla, you can actually smell the sulfur, and I think this is where the idea comes from, that it was the center of the entrance to hell. Partly, this idea was also pushed by religious beliefs, because for a long time, Iceland didn't have Christianity. They believed in the Aesir gods, and of course, most of the writing in the 800s was done by monks, and they wanted to make the point that this is a bad place. So part of the bad reputation of Hekla was actually, again, a propaganda ploy. So Hekla, the word of it is the hooded cloak, if you translate it, and this is partly because it actually captures clouds, and there's a little image on the right-hand side in the middle where you see some clouds hanging at Hekla. They are struggling to get over it. The most recent eruption was only about 24 years ago. It was in February 2000. This is a place we're going to visit, and this is the next one on my list. This is the island of Heimaey in the Westman Islands, and the Westman Islands are called Westman Islands because of the Westman. Westman were actually Irish people. So the Vikings were quite good at, pillaging and taking whatever they wanted, and so they took some Irish people as well. And they were working as slaves, and the story is that some of them got so fed up with their Viking overlords that they fled. They killed their master and they fled. And well, where could they go? They went to the Westman Islands, the Irishman Islands, if you like. And the story goes that it took about 2 years until the Vikings then mounted a little expedition, and they went to the Westman Islands and killed all the Westmans. So that's where the name comes from. Although the name stuck, there is no Westmans left. They're all dead, I understand. And there is a little town there, which is in the center of the island. And it had a rather strange kind of experience. There was a pirate raid on this town in 1627. And this was actually pirates from North Africa. And they came all the way up. And this was not uncommon. We have quite good records of Barbary pirates coming up to Ireland, to France, to actually the south of England. And some of them, well, seems to have made it into the Icelandic realm as well. And there they came in and they took some people again for slavery. So it's a bit bizarre, I find, that, the first people there were probably slaves that were escaping, and then later on, others came and took them. So a very strange story. We will have the opportunity to go there, actually, very soon. And there was a big eruption in 1973. I was only that small at the time, but I had a mentor who was actually there, Professor Stillman, and he took some images, and I got some material from him, so I have first-hand information. And the Eldfell volcano that erupted in 1973 was, of course, a huge problem to the settlement there. So the situation is a bit similar to the Fagradalsfjall situation that we're experiencing now. So in early 73, lava was suddenly erupting from this volcano, the Eldfell volcano, and it threatened to actually fill the harbor basin. So if you look at the photograph in the lower right-hand side, there's the harbor basin, and that at the end of the harbor basin from the right-hand side, that was the 73 lava that came in trying to fill the harbor basin. The Icelanders were very concerned. The harbor is very important. It's the lifeline, the industry lifeline of the island, and the Icelanders brought in fireboats to spray water on the lava, and indeed the lava stopped. Well, I think it was a lucky coincidence. I don't think you can stop lava with spraying a little bit of water on it, because lava is fed from the volcano. If the volcano pumps out a lot of lava, then spraying the front will not do very much. But I think they were lucky, and here's a few impressions. So there, the lava flow going into the harbor basin did not complete its job. The harbor was saved, and it's still active today. Here's a few more impressions. These go back to my mentor, Professor Stillman, and this was a big thing at the time. Very instructive for volcanologists, very destructive for the island. Another major volcanic eruption that happened in the Westman Islands was the eruption of Surtsey in 1963. In 1963, a new island was born, Surtsey. It came out of nowhere, and it was getting famous for one phenomenon, and that is the interaction of lava with water. What happens is that water, well, it converts to steam, and when water converts to steam, it experiences a volume increase. The volume increase is factor 1,000, and that's going to go very rapid, so it's an explosion. Dynamite has a volume increase of about 20,000, so dynamite is still a bit stronger, but this is the concept here. Water and magma is not a good combination, and we still call these eruptions where we have this phenomenon of water explosions, we call them Surtseyan eruptions. Well, we don't have to go through all the details here, but the island formed rather rapidly, and often these islands are not stable for a long time. Surtsey is stable since the 60s, so it's a wonderful scientific laboratory, but I predict unless there will be new eruptions that consolidate the island, sooner or later the island will actually disappear from wind and wave erosions. It made the headlines in many scientific journals back then, and here's a few more impressions. Surtseyan hydrovolcanic eruptions is really a term that has now entered the scientific literature. Whenever we have these phreatic or hydrovolcanic eruptions, we refer to them as Surtseyan. Having said that these islands are not stable, I'd like to draw your attention to this little thing. This is now in the Mediterranean, not in Iceland, but there was a similar story in 1831. A new island formed outside the island of Pantelleria, and the island formed very rapidly, and within a short while every major power in Europe had an expedition there and put a flag on top. So it was called Graham Island by the British, it was called Ferdinandie or Il Giulia by different kind of powers, but well, the island disappeared very, very quickly, and in 1832, the island was gone. All the flags that were put on as well. So we have still the plaque being there by the Italians, and you can dive down there and find it, and this is why Surtsey is so special, because it's still there, despite being in the ocean and exposed to the wind and the weather. So Surtsey has given us a lot of understanding, therefore, because we actually had time. We had several decades now to study this, and here we have a good understanding of how these islands are fed, how they're supplied, how they look inside. So I'd like to move on now in the list of, well, the premier volcanoes in Iceland, and the next one, you can all remember this one, Eyjafjallajökull. So the name was a big challenge at the time, and it's still for many. Well, what does it mean? Well, Jökull, we said, is glacier. Eyja is island, and Fjall is the rock, the mountain. So this is actually the mountain near the islands with a glacier on top. That's what the name means. And indeed, it sits right at the coast where the Westman Islands are. So the islands in the name is the Westman Islands, and the little glacier on top is, of course, visible from a distance, and hence the name. So it started off with a very, very small eruption in 2010, and it was actually going for several weeks as a small eruption until something really awkward happened. And that is the magma that was rising up was hitting a different magma pocket that was sitting in the volcano, presumably since the 1820s, because the last eruption was 1824. And this magma had built up a lot of gas. And when this new arriving magma hit that old pocket, that's when the things got bad. This is when the explosion happened. Several weeks into the activity, suddenly the volcano shifted from being a benign little lava eruption into a nasty explosive eruption. So this is how it looked back then, and the farm is now a visitor center. And there we have this large ash cloud coming up from Eyjafjallajökull, traveling all over Europe, and it was actually reaching what's known as the Blue Banana, the major economic center in Europe that goes through northern Italy, France, Germany, the Low Countries, and it was grinding all the air traffic to a halt, and that was a huge financial catastrophe. So here you get the impression there's a big dark cloud coming up, and it's rising pretty high. There you see a little bit of ash falling out, but the eruption has been going on for several weeks, and it was a serious problem. Let me give you a little impression here. I hope I can get this video to work. So you wouldn't want to be close to that. Certainly I wouldn't. And this was going on for several weeks. And I remember when the eruption happened, I was actually in France with 30 students. We were looking at volcanoes in the Auvergne, and suddenly everything stopped. And, well, the French, they decided to have a train strike at the same time. So I was there, stranded with 30 students, not able to leave the country, and we had to hire cars, and I got the class of 30 students to the German border. There we could get a train all the way to Denmark, and then we had a Dunkirk-style maneuver. Parents and friends came with their cars to pick up students from Denmark. What a disaster. It was the only time I really maxed the limit of my credit card. And whoa, so we all had some memories, certainly. Those people in Europe. So air traffic emergency was the big issue back then, and I was talking about the blue banana. In the lower right hand side you see that blue banana shape. This is the economic heartland of Europe. This is where most industries are located, and this was actually an area affected. Doesn't happen very frequently, doesn't happen very often, but this was a key feature of the time, and this was causing a huge financial loss. Luckily, again, no fatalities. So that's a good thing. Now I'm going to bring you to the big brother of Eyjafjallajökull, Katla volcano. We thought Eyjafjallajökull was bad. Katla is a lot bigger, and it sits right next to it. And Katla had an eruption in 1918, only a small one, but it's a big caldera volcano. It's a big like Yellowstone, maybe not quite as big, but the concept is it's a large crater, and it had literally hundreds of eruptions over the last few thousand years. So there seems to be rumbling there, because only a few days ago we had a Jökullhaup, meaning a glacier flash flood from Katla, and we're not entirely sure whether there was a small eruption under the glacier or whether this was just built up water that found a way out in the end. But here, this is the biggest worry, and Katla has been showing unrest for quite some years. So many of the volcanologists are quite concerned about Katla reawakening. If you thought Eyjafjallajökull was not good, Katla will be really bad. So here we have a few impressions. This is the glacier sitting on top of Katla. So not only is it a large volcano, not only does it erupt very frequently, it also has the glacier, meaning we also have the risk of free magmatic explosions, and it links to Eyjafjallajökull. So somewhere in the subterranean realm, these two volcanoes are connected. It could even be that we have two eruptions that happen simultaneously if it happens to come about. Katla, however, is also famous for something else, and that is it has these beautiful glacial tunnels, and you can go there, you can have a glacier day out there. They drive you up to the glacier, quite fascinating. So let's move on. Part of the Katla system is the Eldgjá fracture system. It links to Katla, but this is now a fissure eruption. Eldgjá means the fire canyon, and this eruption happened in the 930s. We are not entirely sure when exactly, but we're getting better at this. Probably about 934 to 938 or something like this. And it actually was so bad that the settlement period came to a halt. Once this eruption started, people in Norway realized Iceland is not that great, and they stopped coming. This was really kind of drawing a line to the initial wave of settlement. And I actually think that this eruption, the Eldgjá fires, they inspired some of the writing in the Edda, the book that was written in about 1000 AD, which describes all the Aesir gods and all the Icelandic sagas. And there we have several statements that I think hint at volcanoes. So after the Eldgjá eruption, there was also a climate effect of 3 years. And indeed, in the Edda, the description of the end of times is actually what I think is the description of the aftermath of the Eldgjá eruption. There it reads, "There will be a winter with the greatest frosts and keen winds, and the sun will do no good." There will be 3 of these. The writing there continues, "The sun will turn black and the land will sink into the sea. The brightest stars will vanish from the skies. Fires will rage forth and the flames will lick the heaven itself." I like the next one. "Boulders will slam together so big that trolls will tumble, and man will tread the path to hell." Oh, I think this gives you a flavor of the Eldgjá eruption, not the end of time, but still. And there is an independent source, and this is very important in our research. We need independent sources. And in the Saxon Chronicles from northern Germany, there's a reference to this as well. And King Heinrich, who was the first Saxon king, and the Saxons wanted to make him look very special, there's this reference that in the years before the death of King Heinrich, and he died in 936 AD, many signs occurred, they say. And the mountains of the north are said to have erupted in flames in many places likely describing the fissure. So here we have a good idea what happened back in 936, and it was rather unpleasant, I think. We had a similar event, lucky, in 1783 to 1784, another fissure eruption, and again in South Iceland. This was a little smaller, but it produced a lot of poisonous clouds, and the poisonous clouds were also traveling to northern Europe, a bit like the ash from Eyjafjallajökull, and the poisonous clouds had a lot of fluorine. Fluorine is not good for you. You get fluorosis, and that means your teeth fall out. And, well, this wasn't usually happening to people first. It happens to grazing animals. And once the cattle die, the people follow. So there was a big famine after the Laki fissure in 1784, and it's estimated that about 25,000 people perished on Iceland. And there's good evidence that in many areas in northern Europe, there was also increased death toll. Certainly in southern Sweden, we know that the years after the Laki eruption had higher mortality. We can see this in the church records. Here's another big volcano. Now we're moving towards the north. It's Askja volcano, and Askja is also well, rumbling a little right now. It's got several beautiful lakes, and one of them, the Viti Lake, is actually an acid lake. It's got a pH of 1. There's some brave souls who dive in there. Can you believe that? I think I wouldn't risk that, but sometimes divers also disappear. I think if you have the slightest accident while you're diving in acid, it's probably not going to be so healthy. So the volcano will erupt again. It had a large eruption in the 1870s, and this had a huge effect back then because it started a wave of emigration. People were leaving after the Askja 1875 eruption, and a lot of people left for North America. Because the eruption had huge effects on agriculture, livestock, etc., people in Iceland thought, oh, I'm so tired of these volcanoes, so they left for the US. And the eruption also produced a lot of ash, and this was recorded in Norway, Sweden, Germany, etc., and had therefore quite some severe effects. When I read this, I got really interested, and I was wondering, where did the Icelandic people go in the US? And there's a map on the right-hand side. It seems there's 3 to 4 major centers where people went. A lot of Icelanders went to the north, near the Canadian border, for example, so they liked the cold climate. But then some others said, I'm not only tired of volcanoes, I'm also tired of winter and ice and darkness. And some of them went to California. And there you see the little pink areas down there. So this is where most of the Icelandic people went. So the last one I'd like to introduce is Krafla. Krafla is a big caldera complex not so far from Askja, and it had a big eruption series in the 70s into the early 80s, the Krafla fires. It's also a site of one of the best performing geothermal power plants, and a lot of the geothermal technology was developed there and has been exported to other parts of the world. Now we have geothermal power plants also in the southern hemisphere, like in Indonesia, the Philippines, etc. And much of what we learned about how to build them comes actually from Krafla. So there was a weird accident. People were drilling again for more geothermal resources a few years ago, and completely unexpectedly, they drilled into a magma chamber. And you would think, oh my God, but nothing happened. So this magma was sitting there quite happily, and it didn't want to erupt. It was actually not strong enough. It didn't have enough gas. The thing that happened is it melted the drill bit, so that was gone. And this was unfortunate, very costly, but nothing really bad happened. And now there's a big scientific proposal that has just been submitted to the European Science Foundation, where a team of scientists have proposed now that we can drill into magma reservoirs and magma chambers by accident. Why don't we do this purposefully? And then we can learn from it. So I don't know whether the European Science Foundation will fund this. We will see. But this is a phenomenon that I found was quite striking. And Krafla has reached a certain element of fame because of that. So a quick word about monitoring Icelandic volcanoes. Well, there is continuous monitoring. So if there's eruptions, we will find out weeks, days ahead, and nobody kind of died directly from volcanoes, but people, of course, perished from indirect effects like famine in the historical record. However, personally, I think volcanoes have a rather bad reputation. And there's quite a reason for it, I get it, but volcanoes also do a lot of good. So I'd like to conclude the last few minutes with a few good things about volcanoes. Volcanoes are not all bad. Like every human, volcanoes have good and bad sides. So here's the good sides now. So first of all, it's great for tourism. So it saved the Icelandic economy in 2021. We had Fagradalsfjall, and the biggest tourist attraction in all of Iceland is the Blue Lagoon, which is actually the leftover waters from the Svartsengi power plant. And here people go and you can, well, swim in thermal waters. They're very healthy. There's a lot of minerals in them. They're very good for your skin. And you can buy Blue Lagoon cosmetical products there. And it's very famous. Apparently, they sell extremely well in Asia for some reason. And if you have a chance, well, you can go there, but it's also very close to the actual volcano that might erupt. So I don't quite think it's the best spot to go. Maybe choose one of the other thermal pools for now. So, having talked a little bit about geothermal power, of course, volcanoes deliver a lot of geothermal power. It's so much that Iceland is actually the country with the highest banana production in Northern Europe. And this is happening in greenhouses, of course, because of all the cheap energy. Iceland also has several aluminium smelters, where aluminium ore is shipped in from India. It's smelted in Iceland, and then it's shipped back to India, because it's cheap to smelter things with the cheap energy in Iceland. It's plentiful, it's renewable, and therefore we can harvest it. There's a little pie chart in the top right. 40% of the energy is used for electricity production, and then another 40% is used for space heating, and then 2% for greenhouses, fish farming, etc., and even snow melting. So, how does it work? Well, you have steam coming up, hot steam, hot water, and this can drive turbines, and this can, of course, produce electricity. So here's a very schematic diagram where you pump in water, extra water sometimes. We're using this concept of phreatomagmatic activity. We're converting water to steam. That volume expansion can be harvested, can be utilized, and that will drive turbines, and with that we can make electricity. So, another use of geothermal energy is in Reykjavik. There is actually hot water pipes that are going under some of the key roads, and they will be opened up in order to melt ice and snow in winter. So we can do snow melting with the hot waters, and indoors the heat from geothermal power is often used for drying fish. And dried fish is, of course, one of the delicacies in Iceland, and their volcanoes play their role as well. As I said, there's a lot of banana production in Iceland, believe it or not, but also other things. They are farmed in greenhouses, and this is a phenomenon that has been taken off. There's a little diagram on the bottom left, and there you see the increase of these kind of activities over the last years and decades. The Blue Lagoon, I mentioned it before, it's one of the most important tourist attractions on the island of Iceland. It's very nice if there's just not a volcano close by that is erupting. And as I said, there's loads of beauty products. If you happen to be in Reykjavik or at the airport, there you will have various shops, and I recommend it highly. It's very good for your skin, but well, as I said, it's certainly a big seller in Asia for some reason, and I have not worked out why. So, other products that you can get in Iceland is, of course, this one, and I was a bit intrigued to start with, and that is actually, that's whiskey stones. So this is lava rocks, and if you like your whiskey cold, but not diluted, then you can put your lava stones into your freezer, and then you put them in whiskey, and then you have a neat whiskey that is cold. So, well, I think it's a little overrated, this particular product, but of course, in addition to that, Iceland produces these extraordinary landforms and different life forms, from Arctic foxes to puffins, and these stunning and mind-boggling landscapes like here at Fagradalsfjall, and this is what Iceland is famous for. And for me, as a scientist, it's also extraordinary because it's one of the best scientific laboratories for volcanism that we have on the planet. So, thank you very much for your attention, and please feel free to ask.
Ladies and gentlemen, please help me thank one more time Professor Valentin Troll.